Kunkel here. Make sure that you subscribe to my channel and set the notification bell to all so that you won't miss any of my new content. On this episode of Global Talk, we'll be focusing on coatings for water and wastewater treatment facilities. Joining me today is Steve Roeder. He's a business development manager from Sherwin-Williams Company. Steve, welcome.
Hey, thanks. Good to be here, Jim. Thanks.
Could you go through and explain, as a business development manager, what you do for Sherwin-Williams?
Yeah, sure. So, business development manager, I'm basically the market manager in water and wastewater for the Northeast. So I cover everything from Indiana to the East Coast and then up the Northeast.
Okay. Steve, in 2017, the American Society of Civil Engineers, they gave the United States a D+ grade when it came to the wastewater infrastructure. With wastewater treatment being, so critical in the United States, what are some of the current condition issues that are deteriorating our wastewater treatment infrastructure?
Yeah, that's a great question. And it's really a complicated one too. What has three sort of phases to it, but I've worked in both water and wastewater through my 36-year career, and I've noticed far more serious issues on the wastewater side, and these issues seem to go well beyond the fact that we had this corrosive H2S gas present in the wastewater systems. I think to fully understand the question or my answer, I'm going to have to give you sort of a brief outline on how the H2S is generated in wastewater systems, and then why this H2S gas is so damaging. So the wastewater sewage flow is high in high concentration of sulfates. So when you in the wastewater systems, you get this slime formation on the sewer surfaces and the facility surfaces, and this slime creates an anaerobic condition. And the anaerobic conditions allow sulfate-reducing bacteria to flourish. So it's these bacteria, they're in this slime layer that metabolize or eat the sulfates that are in the wastewater stream. And it's a fairly complicated process. I'm not going to get into it, but H2S gas is formed from this process. Well, the H2S gas then goes into the air spaces in these facilities, condenses in moisture onto the surface, and now we have on these surfaces sulfur oxidizing bacteria. And these sulfur oxidizing bacteria take the H2S gas and turn it into sulfuric acid. And this sulfuric acid is what's doing all the damage to the concrete. It's not the H2S gas itself. And these sulfur oxidizing bacteria are particularly attracted to the nutrient-rich scum layer that's just above the liquid surface on the walls. And that's typically where you see the worst deterioration. So there have been three really major changes in the last 40 years that have dramatically increased the corrosivity we see in wastewater collection and treatment systems. Number one, some time ago, the Clean Water Act of 1980 was promulgated. This law mandated that industrial pretreatment to reduce or eliminate the presence of heavy metals in the wastewater discharge from these industrial facilities. So now all these industrial facilities that were discharging metals like zinc and lead, iron, mercury, chromium, copper, they're required to treat this effluent and remove it all before it got dumped into the waste stream. Well, it turns out these heavy metals were toxins for this anaerobic bacteria that was found in the slime layer on the concrete pipe, in the force mains, the tank surfaces. So it severely weakened them, so they weren't creating a ton of the H2S gas while these heavy metals were present in the waste flow. So the H2S was maintained at a fairly low level prior to this Clean Water Act going into effect. The second is the trend towards regional sewer districts. So this trend has significantly expanded the footprints of these sewer systems, and which has required longer travel times in the pipes, longer detention time, and this sewerage becomes more septic the longer it sits in these piping systems. It's also necessitated more force mains because they have to travel longer distances. You can't get gravity feed over those long distances. And the force mains now have caused these pipes to run full as opposed to like half. So now you get this slime layer around the entire diameter of the pipe. So more bacteria now are present to act on the sewerage. And so these two factors have really increased a significant increase in the hydrogen sulfide production in wastewater. But a third thing that's happened is air quality regulations and public relations. Now, because of these air quality regulations we've promulgated and public concerns regarding the odor from H2S and wastewater treatment plants, we've started to put covers over a lot of the facilities. And what these covers do is it traps the H2S inside and allows it to build up to much higher concentrations and collect in the headspace. So, in general, prior to 1980 in the 70s, H2S levels you'd encounter in headspaces were generally, 10 part per million in most sewer systems. Concentrations, you get anywhere from 2 to 10 in the crowns and pump station headspaces, and then in like the headworks, you might get 10 or a little above. Now it's not uncommon to see them several hundred parts per million in some facilities, which has made a huge difference. So this has caused a lot of additional deterioration from all this H2S. And personally, over the last 30 years, I really haven't seen a lot of owners and engineers adapting to these increased conditions. We really seem to be doing things the way we've done them historically, and I think that's why you're seeing a lot more corrosion in our wastewater systems than we have historically.
Very interesting. What coating systems are proven to work with water and wastewater treatment?
Yeah. So, Jim, we really didn't see development of more acid-resistant coatings for wastewater treatment until really it's been the last 10 years where we've seen some real developments. Actually, one of my mentors, I worked for him for a while, Randy Nixon, kind of a giant in the industry, concrete and wastewater. He saw all these issues, and he really pushed the coating manufacturers to really develop technology that could be used on concrete and wastewater that was resistant to these high acid conditions that we see. He was also instrumental in helping to develop what's called the Severe Wastewater Analysis Test, or the SWAT test. And it's now ASTM G210. And this is an accelerated testing protocol to qualify coatings for long-term severe wastewater services. And, that said, I still see a lot of owners specifying older technology. Probably one or two a week. I try to convince not to specify coal tar epoxy, for instance, which is an older technology, and it's just not up to the conditions that we're seeing today. So in general, severe wastewater service, there's really two really good options. The new generation of 100% solids, epoxy coatings are really good, and they've been developed for these conditions. Some of these are reinforced with a microfiber or a glass flake to give them additional structural integrity and help to build the film thickness. And then you have the elastomeric polyurethane technology. If you have afraid you have some movement in the concrete or some cracking, the elastomeric is a good technology. With respect to Sherwin-Williams, our number one offering in this space right now is what we call our DuraPlate 6000. That's a 100% solids epoxy. It's glass flake reinforced. And the nice thing is right now it's the only one on the market, 100% solids epoxy that can be sprayed via conventional spray equipment or brushed or rolled, in addition to the plural component application. So it opens up to a lot more contractor options when you don't have to have the plural equipment to put on it. You can get up to 250 mils in a single coat, neat application with it. Return to service, return to severe wastewater service in 10 hours. It passed the SWAT test, and it has a water vapor transmission rate via the ASTM D1653 of 0 grams per square meter in 24 hours. So it's a really high quality coating. We also have in the elastomeric our Polycoat 110 and Polycoat 115 products that are best in class polyurethane elastomerics that are really, really highly chemical resistant. Again, one coat application, high H2S resistance. They're actually also NSF approved. So is the DuraPlate 6000 is also NSF approved. And has the Polycoat 110 and 115 have returned to sewer service in 12 hours. So those are our main offerings in the severe wastewater service conditions, and they are best in class. So we're proud of them.
So, Steve, concrete is so heavily used in wastewater treatment, and as a substrate, it can be very problematic with protective coatings. Can you cover some of the challenges that concrete might provide to an owner or a contractor, during a coating project?
Yeah, you hit the nail on the head there. So, concrete deterioration does present significant maintenance and rehabilitation challenges. Unlike steel, concrete is a heterogeneous material. So, when steel corrodes, it's really a fairly simple procedure to measure the metal loss, measure how much metal is left, do a fairly simple structural calculation, and you can determine whether the steel is good to go or not, or whether it needs repaired. Concrete's a whole different animal, right? When the concrete deteriorates, it's really difficult sometimes to figure out if there's a structural issue. So that's your first concern. Do we have a structural problem? So once you have established that there's no structural issue, you have to develop a repair and a lining plan to prevent this deterioration from occurring in the future. So concrete is highly alkaline. It has a really high pH. Fresh concrete has a pH of 13 or 14. So it's high. So this makes it really, really susceptible to acid attack. And you know that earlier I mentioned that the H2S turns into sulfuric acid. That's our problem. And there's several different types of acid attack we find in wastewater systems. But the one that we associate with the H2S is what we call, and it's biogenic sulfide corrosion. So the problem with biogenic sulfide corrosion on concrete is that there's two lines of attack that sulfuric acid takes on the concrete. The first one is the simple acid neutralization of the alkaline cement paste. It just deteriorates, it crumbles it from neutralizing it. But the second and more damaging prong of attack is called sulfate attack. And this is very insidious, very dangerous, and this is what causes us most of our problems in wastewater treatment plants. So what the sulfate attack is, the sulfates from the sulfuric acid, it reacts with the calcium components in the hydrated Portland cement, and it creates basically gypsum, calcium sulfate. And these products that are created in this process have a higher volume than the original components that created it. So as they expand, you get microcracking of the concrete, which starts to deteriorate even further, but the cracking also allows deeper penetration of the sulfates into the concrete, and it continues the attack even deeper. So it's sort of self-perpetuating as long as you have the moisture there. Those expansive forces that really are the problem. So a challenge to the owner and engineer when you're developing a repair and a lining plan is you have to figure out how much concrete has to be removed from that surface to get down to sound material that is not contaminated with sulfates. So what happens is, as these sulfates penetrate into the concrete, you may have a layer where the sulfates are present, but the concrete still seems like it is sound. What happens is, if you leave those sulfates in there and you line over them, those sulfates will continue to act on that concrete over time, and they can deteriorate the concrete underneath your repair and your lining and cause significant problems. So defining that depth is tough, right? We can test a pH. That'll give us some sense of how solid the concrete is. But when you're developing this plan and you're going to bid it out, you have to give the contractor sort of an idea how deep he's going to have to go. If you just say you have to remove everything that's deteriorated, then they're going to put a lot of money in their bid to remove concrete that might not need to be removed, right? One of the ways I've done in the past is I've actually taken concrete powder samples with a hammer drill. So you might drill down in 1/8 of an inch, collect the powder up, put it in the bag, go another 1/8, put it in the bag. Send those samples to be tested by a lab for chlorides, sulfates, and pH. And you can sort of develop a profile in that concrete of how deep that penetration was. So you can tell a contractor, in general, we're gonna remove an average of 1 inch of concrete from the surface when we do the when we do the repair. The other issue you have is, I've been in a lot of plants, a lot of facilities where rebar is already exposed and corroding. Sometimes in the concrete removal process, you will expose concrete, part of this heterogeneous system that we have. And if you do not treat that reinforcing steel properly, in other words, clean it to a near white metal blast and coat it with an epoxy coating, you're going to set up a corrosion cell later that is going to deteriorate underneath, again, your repair and your coating lining system and cause significant problems. The nice thing is that concrete surface preparation lends itself well to ultra-high pressure water jetting. UHP can remove a lot of concrete fairly quickly. It's not usually, the removal of the concrete typically isn't the problem. It's the determination of how deep you need to go. That's the problem. So then, once the concrete's removed, a simple pH test of the surface of the concrete will give you a good indication of whether the surface is adequate. I like to see 9.5 as a minimum. 10 is better, but that's sort of where you need to be. The second issue in lining concrete is an issue we call outgassing. Concrete is a porous material and it breathes. So as temperatures increase and the surface temperature of the concrete increases, it releases gases into the atmosphere. As the temperature of the concrete cools, it absorbs gases back in. So if you apply a coating system to bare concrete, while it is outgassing, it'll usually either create bubbles in the coating or actually blow holes all the way through it, create holidays that are then impossible to cover and create significant problems. So we deal with the outgassing in two different ways. Number one is with a primer sealer that we would put over the surface of the concrete that penetrates the concrete pores and seals it up before we come back with 100% solids material. The other thing you'll see contractors do, and I even have seen it specified, is only applying coating to the surface of the concrete during the late afternoon, early evening hours when temperatures are decreasing and the concrete is in its breathing in mode, and you'll get far fewer outgassing problems that way. So those are the major issues with concrete. The minor issues would go on and on for 4 days, so we'll leave them for another discussion.
Yeah, I'll tell you what, Steve, we've covered so much in, such a short time, and you're right. I mean, it's very apparent we could talk about this topic for hours upon hours upon hours related to, water, wastewater treatment facilities. In closing on this topic, is there anything you'd want to leave with the viewers about this topic?
Well, other than the fact that you really need help on projects like this, if you haven't done these, you don't have experience, get help, whether you're an engineer or an owner. Manufacturers have been working hard to develop effective coatings for wastewater service. And I know Sherwin-Williams has been a leader in this effort. If you're an owner or engineer responsible for maintaining wastewater assets, reach out. If you have a local Sherwin-Williams coating specialist you work with, they can assist you getting the correct products specified, the correct procedures specified, because they're critical for the long-term service. You could do a project and end up with 3 years of service, or you could do a project and end up with 20 years of service just because you specify the correct procedures and the correct products. If you're using a spec that has not been updated in the last couple of years, it's really likely that you are not specifying the most current technology that's available. That's how rapidly this industry has been changing here over the last 5 or 10 years. So if you don't know who to reach out to, feel free to give me a call. Jim, you're going to put my contact information, I guess, in the on the page, and I'd be happy to get you in touch with the right person. We can't cover everything here that you're going to need to know to get your project done right. You just need to know the right people to talk to.
Yeah, Steve, for the viewers of this episode, I will have Steve's email, and I also have the site page that's dedicated to this topic from Sherwin-Williams. In closing out this interview, the thing I did not mention at the beginning is that Steve is a past president of SSPC, the Society for Protective Coatings. And as many in the industry know, the NACE International and SSPC are merging together to form a larger organization. Steve, as a past president of SSPC, you contributed so much over the years to the industry. And like you say, in the last 5 to 10 years, this industry has been rapidly changing. Anything you wanted to say related to the potential here with the new organization of a combined NACE SSPC?
Yeah, I think it's exciting. I think it's there's an opportunity to really work together and develop synergies that I think will really move the industry forward. I know SSPC has been very, very, even it's the Society of Protective Coatings, used to be the Steel Structures Painting Council, right? But now we're so involved in concrete. They've been highly involved in concrete surface preparation standards that have just come out that would be used on projects like this. So if you're not involved in the SSPC, NACE organizations, I highly recommend it. There's a ton of technical information. The standards that you're going to need are all included there. It's one of the better organizations that's targeted for a specific sector, of corrosion and coatings that now encompasses steel, concrete, everything. So. Get involved in that for the information.
Well, Steve, I very much appreciate this opportunity to talk with you today, and I'm going to definitely invite you back. So maybe we could work on some other topics, because I'm sure this is going to be a very highly sought after and mentioned episode here. Thank you for your time, and I appreciate the opportunity.
Thank you, Jim. Appreciate it.
Have a great day.
You too.